So I'm Ramez Naam. You've heard a bit about me. I'm going to talk about the broad swath of how exponential technologies are disrupting industries and businesses and what we can do about it. You've already heard, I'm a computer scientist by training. I write books, mostly science fiction, and I teach with Daniel at Singularity University, where we try to take people, educate them on exponential technologies, and encourage them to find ways to apply those to the world's grand challenges to improve the lives of 1 billion people, which sounds very lofty, but it's actually real. This sort of technology has improved multiple billion of lives already. So the technologies we talk about are computing, robotics, AI, nanotechnology, energy, and what we see is that they all have this exponential function. They all are improving in their price performance every couple years. And when we see this happen, we see a set of 4 Ds, 4 steps an industry goes through. First, it gets digitized. Then it gets dematerialized. Then it gets demonetized. And finally, it is democratized. Let's go through what those look like. Digitization of a domain. Well, you've heard a fair bit about self-driving cars. We all hear about it. I don't think there's any in Australia quite yet, but there will be soon. These vehicles are amazing. This is Google's V1 self-driving vehicle. These vehicles have driven about 2 million kilometers on roads right now. They've had 16 accidents. Of those 16, 15 were caused by humans, not by software, and 1 was caused by software. So they are roughly at least an order of magnitude, at least a factor of 10 safer than humans, and 1 million people die on roads in vehicle accidents around the world today. In the US alone, if you take the 50 billion hours that Americans spend driving, plus the cost of accidents and the cost of inefficiency, you're talking about a $1 trillion economic surplus given back to the people in some form if these were ubiquitous. Right? So these things are no longer just in the domain of Google. Every manufacturer is working on self-driving vehicles, from Daimler to Ford to General Motors. Uber has 100 of them on the streets of Pittsburgh today. If you call an Uber in Pittsburgh, you might get a self-driving vehicle. They're better than we are as human drivers for a couple of reasons. One is they have better senses. So they see the world around them using LiDAR, the laser version of radar. So they have 360-degree view, no blind spots. 2 is that their reflexes are simply far better than you or I. They can respond in microseconds to what it might take us whole seconds to do. They also never get drowsy. They also never have too many glasses of wine before they get behind the road. So I'm going to show you what it's like to drive in a self-driving car, or to ride in one, and I apologize in advance. There might be a wee bit of profanity in this video.
Ant's team will never believe this.
Oh my goodness. Go is the right word. Holy shit. Holy shit. There's no fucking hands on that wheel. Oh my god. What?
It's driving itself.
Now, it's not really like that. They actually drive very politely. They drive like your mother, but very alert, very polite, always exactly the speed limit, as Daniel said. But perhaps that's the scream of taxi drivers, though, as Martin Ford was saying. We'll come back to that. Now, there's an old Arnold Schwarzenegger film where he gets in a taxi cab, and there's a robot behind the wheel driving. And that's a naive version of what self-driving cars might be like. But actually, it enables more radical transformation of what transportation is like. So imagine that your vehicle is now a place where you can work or be entertained or sleep or do whatever it is that you want to do. It's not just that something else is doing the driving, it's that this time is given back to our lives or to our economy. It has other implications. Uber just bought this startup, Otto, a little over a year old, $1 billion for this self-driving trucking startup. Truckers can drive 8 to 10 hours legally in most countries. Imagine self-driving trucks that can go 2,000 kilometers a day with almost no accidents. They can convoy behind each other, save 30% of fuel, 30% of carbon emissions, and now you can ship on ground something that is almost as fast as air, but at a fraction of the cost, a fraction of the energy and climate impact. So with self-driving cars, we see this remarkable phenomenon, which is 10 years ago, they simply did not work, and they were nowhere on the horizon. DARPA had contests for self-driving vehicles, and nothing could finish a course. Nothing could go more than a few hundred meters. And then 8 years ago, a team finished the course, and then Google acquired that team. So we have this perception in industry after industry, and in all of human society, that we go from no change to suddenly radical change all at once. But really, that's an illusion of how we look at things. That's a linear view of things. What's actually happening is exponential. And Daniel used this example yesterday at lunch to think about the difference. If I take 30 strides, I'll hit the back of the room, I'll go about 30 meters. If I take 30 exponential strides, and each stride is doubling in length, 2 meters, 4 meters, 8 meters, then I won't go 30 meters, I'll go 1 billion meters, or 26 times around the Earth, right? That's compounding interest, if you will. Every step is bigger than the last. And because every step is bigger than the last, in exponential technologies, we often see that when the initial steps are tiny, you're following that green curve, and you're seeing what looks like no progress at all. And it looks like this new technology is simply useless. A digital camera that has 100 pixels, a 3D printer that prints 1 widget in a week. Those things are not useful to us at all. But if that's doubling, then at some point it crosses the threshold of being very relevant, and then suddenly we're amazed at how fast change is happening.